will start the configuration properly. So let's start this. Let's see how electrons are configured. Having known the orbitals, the number of electrons they can contain, the shells, what are called, and the laws. So let's do configuration and see how it goes. I will start with the first element. First element is hydrogen. Hydrogen. How many electrons is one? One electron, right? What is the configuration I'll be using here for example? I'll be using here. So oxygen, hydrogen takes one electron. It has only one electron, right? This one electron at which this is the number of okay, let me know write this. One electron. This number of what? This is a shell. This shell is the first shell. We write one. Which orbiter starts every energy configuration S? How many electrons do we have here? One. We write one. This is the configuration of what? Hydrogen. Now, this one is linear configuration. Block configuration is like this. This is a block configuration. Block configuration. You write 1s. How many electrons? 1. You write it this way. Block configuration, right? Next one is helium. Helium. Right? Now, helium, we now add 2 electrons here. It has maximum of 2 electrons, right? It has 2 electrons. These 2 electrons, which energy level are they? 1. You write 1. Which orbital start every energy level? S. How many electrons are here? 2. You write 2. Are we there? Now, the block configuration is like this. Like this. That is 2. Sorry. 1s. I write 1s. This is 2 electrons. Right? Like this. So, the third one is lithium. Lithium is how many electrons? Lithium has 3 electrons. No electron can enter here. This here shell is complete. It can take the maximum of 2 electrons. So since it's 3 and this one is complete, we introduce another shell, right? Another energy level. Here I'll add 1 electron. Are we there now? Good. Now here, when I want to start configuration, I must start with the first energy level. First one. Here is 1. 1, right? Which orbital start? S. How many electrons are here? I'll write 2. I'm done with this first one. No electrons remaining. All electrons are finished. So I'm entering the second one. I will use 2 to represent it. This shell is represented by 2 because it's the second one, right? Which orbital starts every energy level? S. I will still write my S because it's a new energy level, right? How many electrons are here? 1. I will write 1. Are we there? I've configured it. Now this is the block configuration. I will have this. This is 1s. I will have this. And I will have this. I'm done. This is 2s. 2s, right? How many electrons there? 1. I'll have it like this. I'll have 2s. Block configuration. Are we together now? Now, is it beryllium? Is it beryllium or boron self? Don't forget. Oh boy. Oh, boron or beryllium. How many? 4 electrons. We add 1 here again. This is 4, right? This is 4. Let's go. I'll have my 1s for the first one. 1s2. Are we there? Now I'll go to the second one. 2. The second energy level. S. How many electrons are there? 2. I'll write my 2. I'll come to this block configuration. I'll have like this. Are we there? I'll have 2 electrons. As 1s. I'll have another one like this, right? I have 2s. This is what? 2 electrons. Are we there? Good. Now another one is beryllium. Are we there? Beryllium is how many? 5. I'll write 1 here. This is 5, right? Good. Our first one, 1s2. Now I have entered second energy level, 2s. How many electrons can s take? 2 only. Now since you can take 2, electron is still remaining here. If I remove 2, remaining 1. At which energy level? Still number 2. I'll still write 2 because this electron is remaining on top of 2 energy level. Which of which s is filled up? Which orbital comes after s? P. How many electrons are remaining? 1. Are we there? Beryllium. Now this is the block configuration. I will have this. 1s. I'll have this. And I'll have this. I'll have this also. This 2s. Right? I'll have this. I'll have this. Now I have P here. Remember, P has 3 atomic orbitals. It must be 3. It must be 3. 3 atomic orbitals. I'll write my 2p. How many electrons are there? 1. I'll write 1. Are we there? Good. Now I have carbon. Carbon is 6. I'll add 1 here. Are we together now? And I have 1s2. Are you there? 1s2 for this one. This one, 2s2. Now, if I remove 2 electrons, how many electrons are remaining here? 2. At which energy level? Number 2. I'll write 2. Which orbital comes? P. How many electrons are remaining? 2. Are we there now? 2. I will now come here and say this. The first one, 1s. I'll have these 2 electrons, right? 2s, 2s, 2 electrons also, right? So one is 2p. This one is by p, like this and like this. 2p. How many electrons? 1, 1. That is 2, right? Remember the law. They must enter single in all the orbitals. If the more than one atomic orbital, enter single in all orbitals before pairing. So the next one I have here is nitrogen. Nitrogen. I'll add another one here, right? That is 5. I'll have 1s2 for the first one, 2s2 for this one, 2p. How many electrons are remaining if I remove 2? 1, 2, 3. 3. I'll write my 3. Are we there now? Here, I'll now write this. I'll write like this. Are we together now? This is my 1s. I have it like this. I have 2s. Are we there? Like this. Now I have 2p. Like this. I have this and I have this. Remember, now if I take 2 electrons, say how many electrons are remaining? 3. 1, 2, 3. 3, right? I'll come here, I'll put 1, I'll put 1, I'll put 1. They must enter single before pairing. So the next one is oxygen. Now, before I do oxygen, sometimes they will ask you, watch, they will say, how many unpaired electrons are there in nitrogen? This is a question in JAMB. How many unpaired electrons are there in hydrogen? How many unpaired electrons are there in hydrogen? I've repeated it. How many unpaired? Unpaired means electrons that are not in twos. That are not in twos. Are not in twos. This one is in 2. This one is in 2, right? These ones are not in twos. So when they say how many electrons are not in pairs in nitrogen, there are how many of them? 1, 2, 3. 3 electrons. Answer. You take 3. 3 electrons are not paired. They are not paired. How many unpaired electrons are there in nitrogen? How many unpaired electrons are there in nitrogen? The number of unpaired electrons say how many? 3. 1, 2, 3. How many unpaired electrons are there in carbon? 1, 2 only. How many unpaired electrons are there in beryllium? 1. Are we there now? These are questions we're going to be answering. How many unpaired electrons are there in this element? For you to answer that question, you must do the block configuration. When you do the block configuration, obeying Pauli's exclusive principle, you will know how many electrons that are not paired, because they must enter single before pairing. If I should do oxygen, let me do oxygen. Last one, then you do the rest. Oxygen. Watch oxygen. Oxygen is how many? I'll put 1 here. That is 1, 2, 3, 4, 5, 6, right? So I'll do the configuration here. Okay, you know what I want to do. So I have 1s2 for the first one, right? 2s2. Remember, it is 6. Since it is 6, I'll remove 2 here. How many electrons are remaining? 4. So I have 2p4. Watch now. I'll have this is 1s. I'll have this 2s, and I'll have this. Are we there? Then this is 2p. This one is how many? 4. I'll first put 1 here. 1. 1 electron is remaining. If I put 3 here, 1, 2, 3, 1 is remaining here. I'll come here and put it, right? Now, if they ask me how many unpaired electrons are there in oxygen, how many? 2. 1, 2 are not paired. So how many unpaired electrons are there in oxygen? 2. How many unpaired electrons are there in nitrogen? 3. How many unpaired electrons are there in carbon? 2. Are we okay now? So this is the linear configuration of elements. This is the block configuration of elements. We use this one to answer so many questions, because they will tell you an element with a configuration. They will write something like this. So it's your duty to know which element is this. How do we know the element? We count the number of electrons. For this one now, this is 2 plus 2, 4 plus 4, 8. Which electrons has 8 atomic number? Oxygen. You got to answer. They write something like this. They say an element with this and this react. So the first thing to do is you check this one. You count the number of electrons. 2, 4, 1. That is how many? 5. So this 5 now, you think because this means the atomic number of the element. Which electron has 5 atomic number, you identify the element. So before you carry out any reaction, you must use this to identify the element by counting the atomic number. Once you count, you now check the element that has an atomic number. That is what it is. So you know whether it's a metal, non-metal, transition metal, non-halide or antilide. So this is the linear configuration, while this one is the block configuration. This one is used to answer questions on pair and unpaired electrons. Are we together now? So now you will continue from fluorine to carbon. We will start, calcium. We will stop at calcium number 20. So that's assignment. You will start from fluorine, then to calcium. Then after that, by 8, we have plenty questions to solve on this. Is it well understood? Yes, that is great.